Hi guys, welcome back. In the previous lectures, we have learned how to implement RESTful HTTP APIs in Go. When it comes to testing these APIs, some people might choose to connect to the real database, while some others might prefer to just mocking it. So which approach should we use? Well, I would say it's up to you. But for me, mocking is better because of following reasons. First, it helps us to write independent tests more easily, because each test will use its own separate mockDB to store data, so there will be no conflict between them. If you use a real DB, all tests will read and write data to the same place, so it will be harder to avoid conflict, especially in a big project with a large code base. Second, our tests will run much faster, since they don't have to spend time talking to the DB and wait for the queries to run. All actions will be performed in memory and within the same process. The third and very important reason for mocking DB is it allows us to write tests that achieve 100% coverage. With a mock DB, we can easily set up and test some edge cases, such as an unexpected error or connection lost, which would be impossible to achieve if we use a real DB. Okay, that sounds great. But is it good enough to test our API with just a mock DB? Can we be confident that our code will still perform well when a real DB is plugged in? Yes, absolutely, because our code that talks to the real DB is already tested carefully in the previous lectures. So all we need to do is make sure that the mock DB implements the same interface as the real DB. Then everything will be working just fine when being put together. But how can we mock DB? Well, there are two ways to mock DB. The first one is to implement a fake DB, which stores data in memory. For example, here we have the store interface that defines a list of actions we can do with a real DB. Then we have the fake DB memStoreStruct, which implements all actions of the store interface, but only uses a map to read and write data. This approach of using fake DB is very simple and easy to implement. However, it requires us to write a lot more code that only be used for testing, which is quite time-consuming for both development and maintenance later. So today I'm going to show you a better way to mock DB, which is using stubs instead of fake DB. The idea is to use Gomock package to generate and build stubs that returns hard-coded values for each scenario we want to test. In this example, Gomock already generated a mock store for us. So all we need to do is to call its expect function to build a stub, which tells Gomock that this getAccount function should be called exactly one time with this input account ID and return this account object as output. And that's it. After setting up the stub, we can simply use this mock store to test the API. Don't worry if you don't fully understand it right now. Let's jump into coding to see how it really works. This is a simple bank project that we are working on. First, we need to install Gomock. Let's open the browser and search for Gomock. Then open its GitHub page. Copy this go-get command and run it in the terminal to install the package. After this, a mockgen binary file will be available in the go/bin folder. We'll use this tool to generate the mockDB. So it's important to make sure that it is executable from anywhere. We check that by running which mockgen. Here it says mockgen not found. That's because the go/bin folder is not in the path environment variable at the moment. To edit to the path, I will edit this gshell.rc file since I'm using gshell. If you're using a bash shell, then you should edit the bash profile or bash.rc file instead. Alright. Now I'm using Vim to open this gshell.rc file. Press I to enter the insert mode. Then let's add this export command. Path equal to $path:, then the location of the go/bin folder. Press escape to exit the insert mode, and $WQ to save the file and quit Vim. Next we have to run this source command to reload the gshell.rc file. Now if we run which mockgen again, we can see that it is now available in the go/bin folder. Note that the gshell.rc file will be automatically loaded when we start a new terminal window, so we don't need to run the source command every time we open terminal. Alright, now in order to use mockgen to generate a mockDB, we have to update our code a bit. At the moment, our new server function is accepting a DB store object, which always connects to the real DB. So in order to use a mock DB in the API server test, we have to replace that store object with an interface. I'm gonna duplicate this store struct definition and change its type to interface. Then this store struct will be renamed to SQL store. It will be a real implementation of the store interface that talks to a SQL database, which is PostgreSQL in this case. Then this new store function should not return a pointer, but just a store interface. We also have to change this object to SQL store, and similar for the receiver of the exectx function and the transfertx function. Alright, now we have to define a list of actions that this store interface can do. Basically, it should have all functions of the query struct, and one more function to execute the transfer money transaction. So first I'm going to copy this transfertx function signature and paste it inside the store interface. For the function of the query struct, of course we can do the same, like going through all of them and copy paste one by one. However, it will be too time consuming because this struct can contain a lot of functions. Lucky for us, the SQL package that we use to generate CRUD code also has an option to emit an interface that contains all of the functions of the query struct. All we have to do is to change this emit interface setting to true, and run make SQL in the terminal to regenerate the code. After this, in the db/SQL folder, we can see a new file called querier.go. It contains the generated querier interface with all functions to insert and query data from the database. And here you can see it declares a blank variables to make sure that the query struct must implement all functions of this querier interface. Now what we need to do is just embed this querier inside the store interface. That will make store interface to have all of its functions in addition to the transfertx function that we've added before. Next we have to go back to the server.go file and remove this star from the DB store type because it is no longer a struct pointer but an interface instead. As you can see, if we click on this create account function, we will be brought to its definition inside the querier interface, which is a part of the store interface as we declared earlier. Note that although we have changed this store type from struct to interface, our code will still work well, and we don't have to change anything in the main.go file because this db.newStore function is now also returning a store interface with the actual implementation of the SQL store that connects to the real SQL database. Alright, so now as we have the DB store interface, we can use Gomock to generate a mock implementation of it. First, I will create a new mock folder inside the DB package. Then let's open the terminal and run mockgen help. Mockgen gives us two ways to generate mocks. The source mode will generate mock interface from a single source file. Things would be more complicated if this source file imports packages from other files, which is often the case when we work on a real project. In this case, it's better to use a reflect mode, where we only need to provide the name of the package and the interface, and let mockgen use reflection to automatically figure out what to do. Okay, so I'm gonna run mockgen. The first argument is an import path to the store interface. I'm gonna copy the Simplebank module name from the go.mode file. Then we need to append db/SQL to the end of this path because our store interface is defined inside the db/SQL folder. The second argument we need to pass in this command is the name of the interface, which is store in this case. We should also specify the destination of the generated output file. Otherwise, mockgen will write the generated code to standard out by default. So let's use this destination option to tell it to write the mock store code to db/mock/store.go file. Then press enter to run this command. Now get back to Visual Studio Code. We can see that a new file store.go is generated inside the db/mock folder. In this file, there are two important structs, mock store and mock recorder. Mock store is a struct that implements all required functions of the store interface. For example, here's the add account balance function of the mock store, which takes a context and an add account balance parameter as input, and returns an account or an error. The mock recorder also has a function with the same name and the same number of arguments. However, the types of the arguments are different. They just general interface type. Later we will see how this function is used to build the stub. The idea is we can specify how many times that function should be called and with what values of the argument. All other functions of the store interface are generated in the same manner. Note that the current package name that Gomock generated for us is mock_SQL, which doesn't look very idiomatic. So I want to change it to something else, such as mockdb. We can instruct mockgen to do that using the package option. All we have to do is to add -package followed by mockdb to this command and press enter. Then now in the code, the package name has been changed to mockdb as we wanted. Alright, before start writing API tests using the new generated mock store, I'm going to add a new mock command to the make file so that we can easily regenerate the code whenever we want. Let's copy this mockgen command from the terminal and paste it here. Also add mock to the phony list. Now whenever we want to regenerate the mock store, we can simply run make mock in the terminal. Okay, now with the generated mock store, we can start writing tests for our API. I'm going to create a new file, account_test.go, inside the API package. There are several APIs to manage bank accounts in our application, but for this lecture, we will only write tests for the most important one, getAccount API. You can easily base on that to write tests for other APIs if you want. In the account_test.go file, I will define a new function, testGetAccount API, with a testing.t input parameter. In order to test this API, we need to have an account first. So let's write a separate function to generate a random account. It will return a db.account object, where id is a random integer between 1 and 1000. Owner is util.randomOwner. Balance is util.randomMoney. And currency is util.randomCurrency. Now go back to the test. We call random account function to create a new account. Next, we need to create a new mock store using this generated function. It expects a Gomock controller object as input. So we have to create this controller by calling gomock.newController and passing the testing.t object. We should defer calling finish method of this controller. This is very important because as described in the comment, it will check to see if all methods that were expected to be called were called. We will see how it works in a moment. For now, let's go back to the test and create a new store by calling mockdb.newMockStore with this input controller. As you can see, Visual Studio Code has automatically imported the mockdb package for us. The next step is to build the stubs for this mock store. In this case, we only care about the getAccount method, since it's the only method that should be called by the getAccount API handler. So let's build stub for this method by calling store.expect.getAccount. This function expects two input arguments of type general interface. Why two input arguments? That's because the getAccount method of our store interface requires two input parameters, a context and an account ID. Thus, for this stub definition, we have to specify what values of these two parameters we expect this function to be called with. The first context argument could be any value, so we use gomock.anyMatcher. The second argument should equal to the ID of the random account we created above, so we use this matcher, gomock.equal, and pass the account ID to it. Now this stub definition can be translated as, I expect the getAccount function of the store to be called with any context and this specific account ID argument. We can also specify how many times this function should be called using the times function. Here times1 means we expect this function to be called exactly one time. More than that, we can use a return function to tell Gomock to return some specific values whenever the getAccount function is called. For example, in this case, we want it to return the account object and a nil error. Note that the input argument of this return function should match with the return values of the getAccount function as defined in the query interface. Alright, now the stub for mock store is built. We can use it to start the test HTTP server and send getAccount request. Let's create a server by calling new server function with the mock store. For testing an HTTP API in Go, we don't have to start a real HTTP server. Instead, we can just use the recorder feature of the HTTP test package to record the response of the API request. So here we call http test.newRecorder to create a new response recorder. Next, we will declare the URL path of the API we want to call, which should be /account/ID of the account we want to get. Then we create a new HTTP request with method get to that URL. And since it's a GET request, we can use new for the request body. This http.newRequest function will return a request object and an error. We require no errors to be returned. Then we call server.router.serveHTTP function with the created recorder and request object. Basically, this will send our API request through the server router and record its response in the recorder. All we need to do is to check that response. The simplest thing we can check is the HTTP status code. In the happy case, it should be http.status_OK. This status code is recorded in the code field of the recorder. And that's it. Let's run the test. It passed. Awesome. Now I'm going to show you what will happen if in the getAccount handler, we don't call the store.getAccount function. Let's comment out this block of code and just set account to be an empty object. Save this file and rerun the unit test. This time the test failed, and the reason is due to a missing call to the store.getAccount function. We expect that function to be called exactly once, but in the implementation it's not getting called. So now you know one power of the Gomock package. It makes writing unit tests so easy and save us a tons of time implementing mock interface. Now what if we want to check more than just the HTTP status code? To make the test more robust, we should check the response body as well. The response body is stored in the recorder.body field, which is in fact just a byte buffer. We expect it to match the account we generated at the top of the test. So I'm going to write a new function, require body match account for this purpose. If we have two input arguments, the testing.t, the response body of type byte buffer pointer, and the account object to compare. First we call ioutil.readAll to read all data from the response body and store it in a data variable. We require no errors to be returned. Then we declare a new getAccount variable to store the account object we got from the response body data. Now let's call json.unmarshal to unmarshal the data to the getAccount object. Require no errors. Then require the getAccount to be equal to the input account. And we're done. Now let's go back to the unit test and call requireBodyMatchAccount function with the testing.t, the recorder.body, and the generated account as input argument. Then we run the test. It passed. Excellent. Now I'm going to open the getAccount handler and change this account to an empty object before sending the response to the client. This time we expect the test to fail because the response body won't match. Let's try it. The test failed, just like what we expected. Okay, so the getAccount API unit test is working very well, but it only covers the happy case for now. Next, I'm going to show you how to transform this test into a table-driven test set to cover all possible scenarios of the getAccount API and to get 100% coverage. First, we need to declare a list of test cases. I'm going to use an anonymous class to store the test data. Each test case will have a unique name to separate it from others. Then there should be an account ID that we want to get. Moreover, the getAccount stub for each scenario will be built differently. So here I have a build stubs field, which is actually a function that takes a mock store as input. We can use this mock store to build a stub that suits the purpose of each test case. Similarly, we have a check response function to check the output of the API. It has two input arguments, a testing.t and a HTTP response recorder object. Now with this struct definition, let's add the first scenario for the happy case. Its name is okay. The account ID should be account.id. Next, the build stub function. I'm gonna copy its signature here. Then move this store.expect command to this function. Similar for the check response function. Let's copy its signature. Then move these two required commands into it. We will add more cases to this list later. For now, let's refactor the code a bit to make it work for multiple scenarios. We use a simple for loop to iterate through the list of the test case. Then inside the loop, we declare a new tc variable to store the data of the current test case. We're gonna run each case as a separate subtest of this unit test. So let's call t.run function. Pass in the name of the test case, and a function that takes testing.t object as input. Then I'm gonna move all of these statements into that function. Okay, now all we need to do is to call tc.buildStub function here with the mock store. Then finally call tc.checkResponse function here with t and recorder. Let's rerun the test to make sure our happy case still works. Yay, it passed. So now it's time to add more cases. I'm gonna duplicate this test data. The second case we want to test is when the account is not found. So its name should be not found. We can use the same account ID here because mock store is separated for each test case. But we need to change our buildStub function a bit. Here, instead of returning this specific account, we should return an empty account object together with a SQL.error no rows error. That's because in the real implementation of the store that connects to Postgres, the db/SQL package will return this error if no account is found when executing the select query. We also have to change the check response function because in this case, we expect the server to return http.status_not_found instead. And since the account is not found, we can remove this required body match call. Alright, let's run the test again. Cool, both tests passed. Let's run the whole package test to see the code coverage. In the account.go file, we can see that this getAccount handler is not 100% covered. Right now, only the not found case and the successful case are covered. We still have to test two more cases, internal server error and bad request. Once again, I'm going to duplicate this test data. Change this name to internal error. Now in the buildStub function, instead of returning SQL.error no rows, I will return SQL.error connection done, which is basically one possible error that the db/SQL package can return when a query is run on a connection that has already been returned to the connection pool. In this case, it should be considered an internal error. So in the check response function, we must require the recorder.code to be equal to http.status internal server error. Now let's rerun the package test. All passed. And we can now see that the internal server error branch in the code is now covered. The last scenario we should test is bad request, which means the client has sent some invalid parameters to this API. To reproduce this scenario, we will use an invalid account ID that doesn't satisfy this binding condition. So I'm going to go back to the test file, duplicate this test data one more time, change this name to invalid ID, and update this account ID to 0, which is an invalid value because the minimum ID should be 1. In this case, we should change the second parameter of the getAccount function call to gomock.any. And since the ID is invalid, this getAccount function should not be called by the handler. Therefore, we must update this to ×0 and remove the return function call. For the check response, we must change the status code to http.status_bad_request. And that's all. Let's rerun the whole package test. Oops, it failed. Looks like the getAccount function is getting called. Let's re-examine our test a bit to see what we did wrong. Okay, I see. Here when building this URL, we use account.id. so it always be a valid value. To correct this, we must use the account ID defined for each test case, which is tc.accountID. This will make sure that the account with ID 0 will be used in the last scenario. Alright, let's run the package test one more time. All passed this time. Great. Now looking at the code of the getAccount handler, we can see that it is 100% covered. So our goal is achieved. However, the test log is currently contain too much information. There are many duplicate debug logs written by Jin, which make it harder to read the test result. The reason is because Jin is running in debug mode by default. So let's create a new main test.go file inside the API package and configure Jin to use test mode instead. The content of this file will be very similar to that of the main test.go file in the DB package. So I'm going to copy this test main function and paste it to our new file. Then let's delete all statements of this function except for the last one. Now all we need to do is to call Jin.setMode to change it to Jin.testMode. And that's it, we're done. Now let's go back to our test file and run the whole package test. All passed. And now the logs look much cleaner and easier to read than before. Okay, so today we have learned how to use Gomock to generate mocks for our DB interface and use it to write unit tests for the getAccount API to achieve 100% coverage. It really helps us write tests faster, easier, cleaner, safer, and much more robust. You can apply this knowledge to write tests for other HTTP APIs in our Simple Bank project, such as Create Account or Delete Account API. I will push the code to GitHub so that you can have a reference in case you want to take a look. Thanks a lot for watching and see you soon in the next lecture.